addresses. Without further ado, let me introduce the introducer for our first keynote address. Our sponsor, Microsoft's Joseph Sirosh, will introduce the first speaker.
Thank you, Jeff. I'm Joseph Sirosh. I'm the Corporate Vice President of Machine Learning at Microsoft. I just wanted to set up Ronnie's talk a little bit. Now, a lot of people think data science is about predictive modeling or clustering or finding patterns in data. But in many ways, it's really about turning data into intelligent action. And when you try to take action with your predictive models, you have to be pretty sure that the action you're going to take has the desired effect, right? Now, in the world of medicine, statisticians have known this for a long time. You might run medical tests, you might develop a new drug, but then when you give it to people, people shouldn't die. So they do randomized clinical trials. And randomized clinical trials is the gold standard in medicine. And way long back, Ronald Fisher did a lot of the work in developing this kind of experimental strategy. And now, in the world of online experiments, and on the web, when you want to take action, today you have the ability to do pretty sophisticated controlled experiments. So you predict things from data, you do controlled experiments, and sometimes even optimization is involved, and you do controlled experiments and make sure that the actions you are taking have the desired effect. And if it doesn't, then you have an opportunity to iterate and refine. You can iteratively refine and learn from the experiments that you're running. Now, Ronnie has worked in this field for a very long time. Now, I've known Ronnie from his days at Amazon. I used to be at Amazon for about 9 years before joining Microsoft. Ronnie joined a little ahead of me in 2005. And he's been honing the science of online experimentation to a fine art through his experiments at Bing. So let me give a little bit of Ronnie's bio. He is today a distinguished engineer and general manager of the analysis and experimentation team at the Microsoft Application and Services Group. He was previously a partner architect at Bing, part of the online services division. He was a general manager of Microsoft's experimentation platform, director of data mining and personalization at Amazon before 2005, and the VP of business intelligence at Blue Martini Software, a very distinguished career in this field. So without further ado, let me invite Ronnie to give his keynote talk.
Good morning, and thanks for inviting me here. As I reflect back on about 12 years where I've done controlled experiments, I think about several events that happened that really changed my career and my life, and one of them was this project that we had at Amazon called Web Lab, which was the ability to run controlled experiments or A/B tests. And we started running them, and when we did enough scale, we looked at the statistics. And the thing that surprised me and a lot of people was how bad we were at predicting the value of our ideas. At the time, I remember the first statistics came out, and 50% of the controlled experiments that we ran at Amazon were not moving the metrics that we wanted to move in the positive direction. 50% of our ideas were bad. When I came to Microsoft, nobody was doing controlled experiments, and I said, hey, we should do these. These are really, really useful. At Amazon, 50% of our ideas failed. And the answer from a lot of people at Microsoft was, well, we have better program managers. Our ideas are much better. Well, I'll tell you that after a while, and we built the whole experimentation platform and have run a lot of experiments. Now, every day, hundreds of experiments run. Our success rate at Bing, for example, is much, much lower, about 20%. Because we've optimized things for so much, it's hard to come up with good ideas. And this humbling experience is one of the things that I want you to get out of this talk, which is when you subject your ideas to objective evaluation on your real customers, you are going to be humbled. A few things. If you want to follow the slides, they're posted here. I also tweeted them under my at Ronnie K and KDD. I own a lot of thanks to a lot of people on the team that helped me with many, many of the things that we came up with, many of the innovations, many of the ideas that we worked with. But let me just get started. So the talk is split into 4 parts. I'll give you some quick experimentation introduction. I think most of you it's an easy audience. You know what we're talking about. Then we're going to play this little game with real examples. I'll share with you some really nice examples. They all have interesting lessons to learn from them. And I'm going to ask you to sort of vote, see if you can put yourself in the pilot seat and see how well you do. Talk about lessons and pitfalls. This is mostly what sort of the thread that goes through this talk about what have we learned in the 12, what have I learned, what have the team learned in the 12 years we've done controlled experiments. And then talk about the last part, which I think is kind of the hardest to deal with, which is the cultural challenges. When you go to a new team and you say you should be running controlled experiments, it's hard. And I'll talk about why it's hard and some cool examples and sort of a model that we have for how we evolve that. So let's start with the motivation, which is product development. There's a nice quote by Richard Feynman there about the theory and the practice of running experiments. But in classical software development, somebody writes a spec, the developers write the code, the testers test the code, and then we release it. In fact, Microsoft had something called the Ship It Award, which was given out every time you finished this process with something that shipped to users. And then it took a long time. In fact, only last year have we stopped giving out this award, realizing that shipping is not the goal. Shipping something useful to the customer is the goal, and there's a big difference there. So what is the model that we like to use? The model is sometimes called customer-driven development. Steve Blank was one of the early people that sort of espoused this. There were some earlier articles about the cathedral and the bazaar and other things, but really Steve Blank's book is one of the books that laid it out really nicely. And then more recently, Eric Ries in Lean Startup. And what have they said? They basically said, you should build a minimum viable product or a minimum viable feature, something that is easy to build, quick, that you can ship out there and test against users in a controlled setting. Then evaluate it, and then based on the result, adjust your intuition, adjust whether this is a good or bad idea. Should you get funded more, funded less? Should you give up on it? It's always that hard step, by the way, that is very, very challenging, because if your idea doesn't work, is it because the idea is bad? Is it the implementation is bad? Could we morph it a little bit? Very, very hard things to determine. So why do you do it? Why should you use this model as opposed to the first one? It's because we are so bad at assessing the values of our ideas. And again, this is a message, this is a thread that I want you to get out of this talk. Why do I love controlled experiments? I've been doing data mining early in my career. We found wonderful stuff. Most of it was promptly ignored. It was very hard to get those discoveries into the products. With controlled experiments, we're in the critical loop. We are out there as software is being built, helping the teams evaluate their ideas and determining if they should ship them or not, or how to iterate. So this is really, really cool for me. As I said, I've been doing this for 12 years, and I really, really enjoy the whole domain. So what is A/B testing? I think, again, this is an easy audience for that. I'll just make sure we're all on the same introductory slide here. You have users coming into some website using some app, some feature that you want to use. You split them into 2 or more groups. And in A/B testing, it's 2. We recommend you split them into more groups. And then you instrument all their interactions, everything you can about what's happening, not only for the user, where they click, how long it takes them, but also on the servers. What do the servers do? How long it takes to compute things? Because you can then correlate this with other things and get more useful insights. The users are real. This is not some professor saying, I tried it with my 12 students from Harvard or from MIT or from Stanford. These are the users that you have using your product. We talk about A/B. This is the simplest form of a controlled experiment, or as I refer to ABN, which is the more common scenario that we see. A, B, C, D, E versions are running. Highly recommended if people work on some design of something, just tell them, try another variant. They sit down and somebody builds some beautiful thing for a couple of months, and then you say, why don't you just try an empty search box? And then you run it in an experiment, and that empty search box that they build on the last day happens to win. And then MVT, I'll just mention this briefly, multivariable experiments or multivariate experiments. We do very few of those. Again, I'll be happy to take this offline with some people here. We value quicker iterations, and it turns out that these are used a lot less than what you believe if you take some introductory stats course that talks about the design of experiments. So in an online setting, we use them a lot less than what one might imagine. And of course, after all these interactions, the numbers comes out at the bottom, the metrics that you're interested in, and they're going to be different for the control and the treatment because different users. And so you have to run simple statistical tests. T-tests are most commonly run to determine if the change is statistically significant. And the key point, the whole reason why we have this infrastructure in place is causality. Right? What you are showing in a controlled experiment is the change that you introduced, if the results are statistically significant, was caused, the metrics change because, or were caused by the fact that you introduced the change. Okay, so let me just give an example. Well, we talk about causality, about something that isn't causal, which are correlated recommendations. Everybody knows about recommendations. I was an Amazon director of personalization, so I can ridicule some of my work. But we did just pure correlations, and that gives some really, really funny things. So here's one. You should buy this anti-aging serum because you bought a light bulb. Right? Very, very unlikely to be causal there. You should buy this Atonement movie DVD because you bought a flashlight. Okay, maybe it's a dark movie. And here's a good one. You should buy this organic virgin olive oil because you bought toilet paper. Right? If there is causality, it's got to be in the other direction. So the whole point of controlled experiments is to come up with something that we can show as causal, not just correlations. A lot of the data mining work that is done is, by its nature, correlational. It's a good way to generate hypotheses. We have a lot of teams who look for patterns. But then when you generate the hypothesis, the trick is to actually make the change, produce an intervention, and see if that is causal. So this is why you run controlled experiments, and sort of the proof in 2 lines is basically the following. When you run the 2 variants or more concurrently, there's 2 things that could be different. It's the feature that you have in B that you don't have in A, or it's random chance. Some people fell into your variant that are better or worse on the metrics that you care about. Because everything else is the same, if we run the statistical test to determine this is statistically significant, we can say that the change caused the metrics to move. This is the gold standard in trials, of course, in clinical trials. And my clicker is working slowly. I do want to say, this is a great way to run things in the software world. It is not the panacea for everything. And if you look up this paper, we list a whole set of conditions that you have to meet in order for controlled experiments to be useful. This is not the solution for everything, of course, but it is a good solution for many, many problems that we see out there. So when I was working in controlled experiments, I was always interested to see, who ran the first controlled experiments? And so at some point, this trumped everything. Right? The earliest controlled experiment appeared in the Old Testament. It was a test for vegetarianism that somebody proposed. But, it wasn't peer-reviewed, and it was written hundreds of years after it happened. So what is a good controlled experiment? And this is normally the first controlled experiments that we assign to science. Scurvy was a disease that results from vitamin C deficiency. Most of you have never heard of this disease. It doesn't exist anymore. Today we understand the reasons. But at the time, this was a very, very serious problem because long-term sailing voyages started. People were out at sea for months and years. They were not exposed to vitamin C, and they had this disease. How bad was it? 100,000 people killed in a couple of centuries. This is an amazing voyage by Lord Anson. Right? He started with 1,800 people, 4 years circumnavigated, and then ended up with 200 people. Right? Most of the people died from scurvy, and they didn't understand why. So here's this doctor called James Lind. He notices the Mediterranean ships have fewer cases of scurvy. Maybe it's the lemons and the oranges that they get. So the story is he runs this controlled experiment, takes people, sailors, gives them lemons, takes other people, gives them the normal diet. And the experiment was an amazing success. And if you look up, the British still call sailors limeys. It's an amazing story, right? The problem is it's really, really a lot worse, or not as good as the story implies, right? So let me tell you the real story. Right, so this was run on 12 sailors, right? I always imagine this big ship, he splits them into half and half. Of the 12, he split them into 6 groups of pairs. He gave the pairs different treatments, right? So some of them get cider, some of them get elixir, one pair gets vinegar. Seawater, can you imagine giving people that? Nutmeg. And then only 2 sailors were given 2 oranges and 1 lemon. And they recovered, both of them. So being a scientist, he says, okay, maybe this is going to work. And so he concentrated the solution, thereby killing the vitamin C, and gave up on it. So here's a guy that works at a hospital and treats about 300 to 400 scurvy patients. He has a 500-page massive book that you can get on Amazon these days. I actually got it and read some of it. Very, very hard reading. But there's only 2 pages about this experiment. Everything else is about all these other ways to treat the disease, including bloodletting, Peruvian bark, rubbing the belly with worm olive oil. In fact, he notes that this experiment was successful, but it can't be such a simple solution because the disease is so complicated. So one of the lessons, and this happens to us all the time, is even if you have a winner, we don't always understand why. Somebody ships a treatment that works, and we don't understand why it worked. And we have to run experiments around it and change things, especially if this is something that changed multiple factors. It helps us to study the area to develop some better understanding of what's going on. Okay, so I've been fortunate to work at an organization that's very data-driven. A lot of the experiments that we run are on Bing. And just to give you the scale, we finish about 300 experiments a week, and because they usually run for about a week, which is, by the way, different than how Google runs things, which tend to run longer experiments, there's about 300 experiments that run concurrently on the site at any given point. And these are, by the way, real experiments. So you'll hear some people, some vendors say, oh, we run 100,000 experiments because they run some multivariable experiments with 30 times 10 times 10, and they get to high numbers. These are really experiments that we design, and somebody spends the time. They're not just a parameter sweep. We do those. They're useful. They don't tend to be as useful as people imagine. So there's a good paper by Google on overlapping experiments that I recommend that you read about how to scale. And we wrote a paper a couple of years ago on how to scale and some of the challenges with it. It's interesting. I mean, with such an amount, you have to build systems that automate shutting down experiments when something goes wrong. You have to have alarms in place. You have to help the users interpret the results. A lot of interesting challenges that we've learned. Scale of exposure to users, just to give you an idea, we typically expose at a minimum 100K. We actually opt for usually millions of users. And then when we have suspicious or concerns or some problems, we will expose this to tens of millions of users. And the reason that we pick such big numbers is that we have to make sure that some metrics actually don't degrade. It's actually the opposite of what sometimes people think. You can move a metric that is your feature, and it will move quickly because you've changed that feature. What you want to make sure is that users don't abandon more, or that the revenue doesn't change. Those are harder metrics to move. They're high variance, and therefore they need a lot of users to make sure that they don't move. If we have a movement of 0.1%, it's several $1 million. So we want to make sure that we don't degrade some of the metrics by that. All our users are basically in experiments. So we keep a holdout of 10% of users that are out of all experiments, and that's mostly to make sure that our system is not hurting. So we have an uber-controlled experiments between that 10% and the 90% of users that are in experiments, but basically everybody is being experimented with. And that causes some interesting challenges. So there's no Bing anymore, right? If you think about it, you go into Bing, you happen to fall into some 15 experiments that are running concurrently on the site. So you're in one of 30 billion possible combinations. So each one of you gets a different version of Bing, which kind of makes it hard to do debugging, right? So we have tools in place that when somebody reports a problem, which experiments were they in so we can replicate it and see what's going on. So very, very interesting challenges there. And then there's the graph here, which is kind of interesting. We, for years, just had issues with getting the systems to scale. Lots of data, massive amounts of data. And people were waiting to get some users to run experiments. And now we're at the point where the system's no longer a bottleneck. We sort of started to plateau as people are now moving to other areas, mobile and other things. But that's sort of the scale that we have. And it's very similar. You can see Facebook runs larger numbers of experiments, about 800 to 1,000. Google runs about 1,000 experiments. We run in the hundreds of experiments. So very, very impressive scale. OK, so next part of the talk is real examples. This, I think, is always fun. I want to share with you some real examples. People have worked on them. People thought they were going to work. Some of them did. Some of them didn't. You're going to have fun trying to guess which one worked, and you'll see how humbling the experience is. So there are lessons attached to each, and I'll share them as we go along. All had enough users for statistical validity. You don't have to worry about it. And then for each experiment, I'll share with you what is called the OEC, the overall evaluation criterion. This is the metric that you wanted to look at for that experiment. And I'll talk later more about the OEC, how it's designed. It's a really, really challenging problem. But for these examples, I picked relatively simple metrics that everybody can understand, and they make the experiments easy to explain and have fun with. So we're going to play this game. So the first, I know it's the morning, I want you to stand up. Let your laptops go for the next few minutes. So here's what I'm going to do. I'm going to show you an example, an A-B. I'm going to give you three choices. Either A wins, you're going to raise one hand, or B wins, you're going to raise the other hand, tell you which one. Or if you think they're not statistically significantly different, you won't raise a hand. Okay, very simple game. And then I just want to point out, there's 1,200 people registered for the conference. Let's say 2/3 of you are here that didn't sleep through. So let's say 800 people. There's going to be 4 examples, 1.2%. So I'm expecting about 10 of you to stand up if everything was completely random. Okay, if you were just completely guessing. Now let's see how better you do than random. This is really the fun part. Okay, so first example, MSN homepage. The metric of interest, the OEC, is the click-through rate. Okay, for this search box. So here's the search box in version A, search box for version B. And I'll point out some differences. A has a taller search box, so that white space is bigger than this. But here's an important lesson. The overall size has to be the same. Okay, why? As a general rule of thumb, you make something bigger on the page, people will click on it more. Okay, so if one of the search boxes was bigger, it'd be an easy call. That one would win. But when the search box is bigger, it cannibalizes other parts of the page, and then you look at the whole page click-through. In this case, the overall size is the same, so we can focus only on the search box. Okay, so even though this is bigger, the overall size is the same. There's some other differences. Of course, the icon here is a magnifying glass. Here's the word search. This one says popular searches. This just lists the popular searches. Okay, so a few differences between these two versions. Again, somebody thought, hey, one of them is better than the other, and built the feature. So raise your left hand if you think A wins. Raise your right hand if you think B wins. Don't raise your hand if you think they're about the same, so no statistically significant difference. Look around you. Lots of people are raising the right hand. Lots of people are raising the left hand. Most people are convicted about one version of the other, which is very, very true in real life. Nobody wants to be spineless. But that's actually what happens in real life. Okay, if you raised any of your hand, please sit down. Wow, that's a lot worse than random here. About 1/3 of our experiments show no statistically significant difference. Somebody built a feature, they thought it would work, it did nothing. The worst case is about 1/3 of our experiments actually hurt. That's even worse. Okay, so first of all, the beauty is get the data. People can debate. You can have all these discussions in the room about which one's going to win, or you can just build a damn thing, throw it at the users, and get the answer. Okay, next example. Bing ads with site links. So let me go to this side. Oops. Should Bing add site links to ads? Okay, so here's an ad. Here's the same ad with these site links at the bottom. Okay? Now, remember I told you before, if I make something bigger, it's going to get more clicks. So If this was the experiment and all I looked for was money, that would be unfair. The right one would win, hands down. So what do we do in order to avoid this trap of just making something larger on the page? We put a constraint on the team. We say, on average, the number of pixels that you're presenting to the user, the vertical pixel space, has to be the same in A and B. Okay, so let me make sure you understand this constraint. If you display version A, which is only 3 lines, you can display more of them. If you display version B, you have to show less ads, either no ads on the page in some cases or fewer ads, right? There's multiple ads on the page. But on average, if we average all the vertical pixel that you take up on ads, it has to be the same for the version A and the version B. And that makes this experiment much more challenging to determine because, is B going to win? Is that information presented in the site links so much useful that we can show only 75% of ads for version B? Okay? Now, there's one more thing here. Version B is 5 milliseconds slower because it takes us a little bit more time to do the compute and because the page is a little heavier. It's got a little more HTML on it. So these are the 2 pros and cons of building this feature. Okay, so again, it's an idea. We ran the experiment. We got the results. So now think about which one would win. Right? So raise your left hand if you think A wins. Raise your right hand if you think B wins. And don't raise your hand if you think they're doing about the same. Okay. Cool. If you raise your left hand, you were wrong. Please sit down. If you did not raise your hand, you were wrong. Please sit down. Now, this feature was debated. Turns out it's worth tens of millions of dollars annually for Bing. Right? This is not something easy. I mean, tens of millions of dollars were generated by this experiment. Now, let me tell you something more surprising. I can't talk about these examples, but we've had cases where somebody writes a feature over the weekend, and it makes $100 million for Bing. Those are the breakthroughs that always amaze me, right? We sit down, and the relevance team moves by, a small percentage, and the revenue team, the ads team moves by 1% every month, and it adds up, once you move 1% every month, after a couple of years, it adds up to a big number. But these things are certainly the spikes where somebody launches a feature, and that makes us $100 million in revenue. Okay, third example, SERP truncation. SERP stands for Search Engine Result Page. This is the standard page that you're all familiar with when you search on a search engine. The OEC is click-through rate. Okay, so we're looking for, you show a page, do people click, and we're only limiting, again, I'm going to make it simple, not having to worry about back buttons and everything. This is the first time the page is shown to the user. What is the click-through rate on that page? So don't worry about page 2 and clickbacks and other things. And version A is the classical show 10 algorithmic results, right? Everybody talks about the 10 blue links. Version B is the same, except we show only 8. Okay, so we take the bottom 2 results and we truncate the page. Everything else stays the same. So all the decorations on the page, the related searches, everything else stays the same. It's just 8 or 10. Okay, raise your left hand if you think A wins. Raise your right hand if you think B wins. Don't raise your hand if you think they're doing about the same. Good question. No, so as you can think here, I'm just going to break at 8. I'm not going to show 9 and 10. So the page, yep, it's going to be white. Well, the page will end, right? So the page will end earlier. We're not making fonts bigger, and we're not doing anything else. Think about just removing those last 2 results. Okay? So what's your vote? Okay. I see a couple of people raising hands. These guys are not raising their hands. Wonderful. Okay, if you raised any hand, please sit down. Now, the question that you should ask yourself, are these really the cream of the crops, or are they just lucky? Right? We're now worse than random. Okay, so last year we gave a paper on rules of thumb, and one of the surprising things that we see over and over again is this rule of thumb that you can basically assume that the click-through rate on the page is going to stay the same. We have done huge number of experiments, removing things, adding things. So what happens here is people just don't click on the last two, and they spread their clicks, the same number of clicks, on the results that we have on the page. And page became a little faster. And so at Bing, we now show 8 results. Even though everybody says 10 blue links, it's really 8. And this is surprising because we have done variants of this where we removed features and added features, and click-through, the abandonment rate or the first page click-through rate just stays the same. So pretty interesting results. Again, you can look at the details. We've even tried experiments where when we show a D card, which is this expanded card for the first result, we truncate everything below result 4, and the click-through rate does not change. Now, if you go too much and the page looks empty, like if the first page has a lot of white space, then people will notice it and file bugs and keep complaining that there can't be only 4 results. But if the page looks okay, and then people just don't notice it. Okay, last example, underlining of links. So I've zoomed in, and the question is basically the same. Does it increase or increase the click-through rate? You can see here on the left, all the links are underlined, and on the right, they are not underlined. Okay, OEC, click-through rate on the first SERP, just as the previous one. So raise your left hand if you think A wins. Raise your right hand if you think B wins. Don't raise your hand if you think they're doing about the same. Okay, we got 1 hand, we got no votes, and we got 2 lefts. Okay, so if you raise your hand, you were wrong. Please sit down. If you raise your right hand, you were wrong. If you did not raise your hand, you were wrong. So underlines improve click-through rate very nicely. Now, if you look at modern web page design, most sites have just done away with underlines. There's always a question about whether this is some long-term effect. We've run this for months, and we've been able to replicate this result. But there's an interesting question in our world about whether the modern design that many sites have opted for is the correct thing to do. When you have underlines, people click more, people click faster to the results. Many of the metrics move in the right direction. Yahoo did something interesting, by the way. Yes, question.
Is the difference really that big? Very significant.
Oh, yeah. It's very significant. Yeah. It's not just as it's significant for our user metrics, it impacts revenue in a way that we care a lot about. Okay, so Yahoo did something interesting. Because underlines attract the clicks, they only underline the ads. So that causes people to go from algorithmic results to ads, so they make more money. But of course, they suffer at the expense of an inconsistent page that has some links underlines and some links are not. Okay, so that ends the second part. Let me move to the third part, which is some lessons in pitfalls. So first of all, hopefully I've convinced you. By the way, you guys, thank you very much. You can sit down. You've been standing for a long time. Congratulations. See us at the booth later on for a job. No. This was our main reason for this test. Okay, so it's hard to assess the values of ideas. Hopefully I've convinced you of that. Some of the statistics that we shared, most of our ideas fail. People build features because they think they're useful. There's nobody that says, let's build this thing, but it's going to fail anyway. We do have learning experiments where we know something we fail, and we want to understand the degree that something fails. For example, we run slowdown experiments. We will intentionally slow down the website to see whether we should invest more in speeding it up. Right? That's a great experiment to do. But most of the time, features are built because people believe they're useful. We joke that our job is to tell you that your baby's ugly. Right? Everybody thinks their new idea, their new baby is just beautiful. And then we go and tell you, oh, it didn't do anything, or worse. You hurt the metrics, man. Shut it down. Okay. This is the general statistics that we've shared. If you look across multiple teams, about a third, a third, a third. Some are positive, some are flat, some are negative. As I said, at Bing, it's a lot worse because we've been optimizing it for so long. It's hard to get good ideas out there. We stand about 20% of our ideas tend to actually be positive. And this has been documented. This is not that Microsoft PMs are worse and Amazon PMs or program managers are bad. This is sort of the reality of the human nature, that once you've optimized the easy things out, it gets harder and harder to build some stuff. So if there's a lesson here, it's just make sure that you run experiments. You'll be humbled. Really, really humbling. So what does that mean? So first of all, avoid this temptation to build optimal features, right? We've seen teams, in fact, this is sort of the classical Microsoft, there's planners that work on it, there's developers, PMs work together, and product released after 3 years. And then it turns out, most of the features are useless. Experiment often. If you have a great idea, have lots of them. An amazing quote. This is a great one. If you have to kiss a lot of frogs to find the prince, find more frogs, kiss them faster and faster. Right? This is about making that cycle faster. And that means, for example, the experimentation platform should have a low barrier to entry in the sense that it should be easy for you to run experiments. Projects always run late, and then they go, why don't we just ship it? No, you should test it first because you may be wrong. And then, try radical ideas. You may be surprised. Right? There's a great talk by Sir Ken Robinson about this. If you're not prepared to be wrong, you'll never come up with anything original. It's Wymans Law. Any figure that looks interesting or different is usually wrong. This is just something that we constantly hit upon. Something amazing happens, and there's a reason that is not to do with your feature or your idea. So here are some examples. We found, there's some data mine that I've done. If you have a mandatory birth date, you are going to find a lot of people who were born on 1/1/1, right? Or 11/11/11. That works with the auto repeat. People do one. If you have an optional drop down, do not make it alphabetical. The first entry will have most people on it, right? This jobs equal astronaut is a common one. And then this thing, which I've hit so many times, somebody discovers on some day we have 5% more revenue, more traffic, and then you look into it, and it turns out it happened in 1 hour in the middle of the night where we doubled our traffic. What the heck? I've seen this so many times where somebody comes up with this amazing discovery, only to discover daylight saving. Right? That hour happens twice. And then there's an outage 6 months later. We were down for a full hour, guys. Did you know how bad things were? So if you find something amazing, somebody runs an experiment, revenue doubles. Wymans Law. Somebody's logging the revenue twice by mistake. Happened. Lots of these happen. So if you see a massive improvement in your OEC, in your overall evaluation criteria, call it Wymans Law. Dig deeper to understand. Now, some of these are breakthroughs. They are just really, really rare. So the OEC, if there's a slide that I want you to remember out of this talk, it's this one. Make sure you know what you're optimizing for. I've talked to groups, got into the table, the big meeting with all the managers. They want to do A/B testing. What are you optimizing for? Ronnie, we read your slide. We are ready. We are optimizing for time on site. This was a support organization. I asked them, is more better or worse? Now the room was split in half. So it's a really, really tough one. So a few things. One, some people call, in lean analytics, they call it the one metric that matters. We usually have a few. Don't take too many. Take a few. But getting agreement, if you can get your org to agree on the OEC, that's a massive step forward. Some guidance that I can give you is think about long-term, lifetime value. Okay, what are the metrics that are going to predict that this user will do something in the long term that is useful for us, for the organization, for the business? I'll give you one cool example from Amazon when I joined. I had one of the teams, they were sending emails. The OEC was revenue or profit. Okay? Now, what's the problem with this OEC? The more you spam, the more money you make. So that team started to spam the users a lot with emails. Why don't you buy this? Why don't you buy that? So the team said, woo, lots of complaints from users. Let's build a traffic cop. We only allow one email per period, per week, or per 3 days. And there was this whole optimization system that was built around which email should we send in this 1 week period when we are allowed to mail this person. The problem was the OEC was bad. What is the better OEC? Profit that you made from the emails minus the number of unsubscribes times your lifetime value through emails. Right? So if you take and say, X percentage of, some percentage of people unsubscribe because of my email, I've lost all ability to communicate them by email in the future. What is that worth? Pick a number. We picked small numbers like $3. Half the email programs failed to pass the new OEC. Okay, so when you have a good OEC, you will find that you're optimizing in very, very different ways than if you just come up with constraints or optimizations or things like that. Great book, recommend it, How to Measure Anything. Talks about the value of perfect information, which is really what controlled experiments give you, sort of that information that you need to get. If you use funnels, very, very common way to use controlled experiments is in a funnel. You have a 3-step process to do something. Then, organizations that look at that, they look at pirate metrics, acquisition, activation, retentions, revenue, and referral, pronounced ARG, hence pirate metrics. Don't be afraid to come up with a criteria. We prefer, by the way, that you come up with a criteria that is one number at the end. That makes a lot of decisions easier. That gives you sort of a 0-1 ship, no ship decision. It's okay to weigh things. Think of your FICO score, which is a number at the end. We have such a thing at Bing where we weigh multiple metrics to determine if something is shippable or not. But that's a great way to, if you're able to arrive on that, it's a hard thing to do, then you've made a large step forward. Think about conversions from actions, time to action, visit frequency. Use a few metrics. Don't come up with 50, right? There's a problem. The name for this is Otis Redding. Those of you that may be familiar with the singer, he's saying, I can't do what 10 people tell me to do, so I guess I'll remain the same. Let's see if the audio works, so I'll remind you of that song.
I can't do what 10 people tell me to do, so I guess I'll remain the same. Sitting here.
Right? So this is analysis paralysis that people get into. Optimize these 75 metrics, and you'll be good to go. Pick a few. At Bing, we have 4, by the way, that we weigh. But then there's the tendency to do the opposite, which is, let me just look at the 4. That's all I care about. So we recommend that you have a lot of metrics. And that's useful for diagnostic purposes. When your metric doesn't move in the way that it should, why? Remember, this is one of the hardest problems, is the why. And so on a typical experiment on Bing, we report on about 1,000 metrics. If something is not done well, people still need to drill in. They change the template, and they get 4,000 metrics. Okay, now, those of you that are familiar with multiple testing, you got to be able to interpret those scorecards, because you're going to get a lot of false positive, but there's ways to sort of trim, and we've developed some mechanisms to help do that. And there's false positive discovery rates. There's a lot of things that you can do to help. But this is a very, very sort of important contrast. Make sure the decision to ship a feature or not is based on a small set of metrics. But for diagnostic purposes, for the learning, throw out anything you can out there, because you may be surprised that that metric that you didn't think was relevant suddenly moved, and the p-value is 1e minus 20, which happens to us a lot. Something surprising moved. There's a low p-value. We know this is real. And then, for this conference, there's a couple of papers I just want to mention. There's a Google paper called Focusing on a Long-Term, really nice discussion about the OEC and how sometimes you have to run experiments long. We, by the way, have achieved similar purposes through other means. We look at some sensitive metrics that are predictive, that we believe are predictive. And then there's another paper on trying to look at not just at means, which is very, very common, but looking at some distributions. So let me make it real for you. Bing, right? What's the problem? The problem is, what should we be optimizing for? So there's a KDD paper on that, but I'll just share with you the gist of it. If you look at the high-level metrics, right, what is the head of Bing being asked to do? 2 things. Query share. What percentage of queries are coming through Bing? In the US, for example, it's about 20%. Google's at 60%. So we're trying to raise that, right? When Bing launched, it was 8%. We've grown every month since the launch, or at least non-monotonically increasing, or monotonically non-decreasing is the way. Some were zeros. But we managed to get up to 20%. Okay, so that's one key metric. And the other one is money, right? Always a good thing is to make more money. But here's a puzzle for you. So if these were the metrics that we were using, look at this bug. So we had a ranking bug, right? The ranker ranks the search results, puts them on the page. Had a very, very serious bug. Results were really bad. Okay, what happens then? Okay, when you display the graded algorithmic results, users have to search more, right? So they issue more queries. And then the ads that normally are mediocre suddenly look really, really good. So people click on the ads. So there's more query share and we make more money. Fire the relevance team. Right? So, this, by the way, this is the actual numbers that were, right? So we had 10% increase to queries and revenue went up 30%. Okay, so what should we be optimizing for? So here's something cool to share. Just a very simple decomposition. You look at your queries, or query share, or queries per month, and it splits into queries per session, times sessions per users, times users per month. And you can see that these just cancel out. Very simple math. A few things about this. We would like to use task and not sessions, but we use session, which is sort of an interval split with 30 minutes of inactivity. But here's the key observation. We want this term to go down. Even though we're trying to increase query share, we want you to do fewer queries per task or per session. Right? And this is sort of the reason why the queries is a bad metric, because this piece of it has to go down. And of course, the sessions per user is the thing that has to go up. And this is the number one metric for us to optimize. Are we able to get users to come more to our search engine? Right, so this is a key observation. The last term, of course, is fixed. The number of users in the experiments is predetermined based on your percentages. So it's really this term that is one of our components in the OEC. Okay, get the stats right. Getting numbers is easy. Getting numbers you can trust is hard. Okay, there's like 2 really good books on Amazon that share a lot of good examples on A/B testing. Here are the 2 books, from Optimizely founders. And then we got by Chris Goward. Both of them get the stats wrong. Right? They're beautiful stories in there, very fun reading. Both of them tell you to stop when something becomes statistically significant, which is wrong. And Optimizely recently updated their stats. What do we use to help us find issues with our methodologies? AA test, number one thing you should do. Okay, what is an AA test? Just like an A/B test, split the users, measure everything, but they both get the same experience. If you're doing AA tests correctly, you should have 5% of the experiments be stat-sig if you're running with a p-value of 0.05. Okay? You will be amazed how many times our AA tests, when we start with a new client, don't end up passing this simple methodology. And even when we come up with new metrics and we compute the confidence intervals incorrectly, somebody implements it wrong, or the metric needs a special computation. We have documented some metrics that just fail under the normal assumptions, under the normal formulas. AA tests are the friends, are the data collected according to system of record. When you have a system that does the A/B testing, you get the same numbers as the system of record. Always a good thing to do when you run controlled experiments. Okay, this is another one that's surprising. Run large experiments. Unless you're running a large site like Bing or Google or Facebook, most of your experiments should be run at 50-50 or close to 50-50. Why? Well, remember, to detect some effect, you need to expose a certain number of users. Right, so you can do this over a very long period of time, or you can do this over a short period of time. We recommend a short period of time. Right? There's a lot of advantages in terms of agility and things like that. Of course, we still recommend you run for a week just to see some day-of-week patterns and things like that. There's 2 things you can do really to help your sensitivity. You can have more users, right? Or, actually, this is not the right slide. So, large number of samples increase your sensitivity. The more users you have, the better it is. Of course, if there is some effect and you have more users, the p-values will go down, which is a good thing. You want the sensitivity to be better. And then so the fastest way to achieve this is 50-50. And again, as I mentioned, on large sites like Bing, we don't have to run 50-50. We typically run 10 to 20%. Still very, very large numbers. The issue with running 20% is allows us to run what are called disjoint experiments. These are sometimes very important to us. You run things that you know conflict with each other. They have to be on what we call the same number line so that they don't conflict to get disjoint users. Okay, this is one of the hardest things, is to reduce the variance. Coming up with metrics that are more sensitive is hard. Here's an example that I gave. If you make a 1% change to revenue per user, it's worth tens of millions of dollars. So if you run an experiment on a small population and you're not able to get sensitivity, you may be losing tens of millions of dollars and not knowing it. Right? This is why we force all our experiments. You can start small, do whatever you want. At some point, you run an experiment that is the real thing to ship or not to ship, has to be 10%. And if it triggers, it has to be 20%. So what are some techniques to use? I'm not going to go through these, but there's some good techniques to help you reduce the sensitivity. A few things about how online is different than offline. You know, there's a nice quote there about how the difference between theory and practice is larger in practice than in theory. But the things that we can do online that we can't do offline are ramp up. We can start experiments small, 0.5%, see that nothing bad's happening, automatically ramp it up. Or if it's bad, shut it down. So we tend to do ramp ups. We have a whole alerting system in place. We log lots of data. Tens of terabytes per day are being logged. Thousands of attributes. Every page that we show, we log thousands of attributes. And there's a lot of challenges about how to get the metrics to work right. And then, of course, I mentioned there's a large problem with false positive. That large number of metrics, that large number of experiments, we have to deal with these problems. Click instrumentation, one of the most annoying things. You can either instrument clicks so that they're reliable or fast. Can't do both. Okay, so there's a lot of issues with whatever click mechanism you use. You're either losing users or you're losing the clicks or you're slowing them down. Bots. Half of our traffic is bots at Bing. Half of the requests that we get come from automated traffic, non-human traffic. We have to deal with that. Right? So we don't have to worry about returning results as fast. We can give crappy results. We do some things to save money that way. Carryover effect. If you're experimenting on users and you do something really bad, that user will behave differently in the next experiment. So it's important to shuffle the users a lot so that you balance the badness or the abandonment that you've introduced as a selection bias. And then I mentioned performance before. We run these slowdown experiments. They're documented in our papers. But the gist of it, even today, where now we are returning results in sub-second on the server, every engineer that improves the results by 10 milliseconds, remember your eye blinks at about 250, 10 millisecond improvement, you pay for your fully loaded annual salary. Not a bad thing to motivate performance. Okay, the cultural challenge, the last part of the talk. Great quote, difficult for a man to understand something when his salary depends upon him not understanding it. People don't like to run controlled experiments because it's their job to make the decisions. Right? We get paid to select the headlines. We get paid to come up with ideas. Why don't we just do the right thing? It's in our DNA. These are all things that we've heard. Right? So I'll take you through a 4-step process, which is pretty interesting about what we see as the cultural evolution. The first stage, called this hubris. Right? And I'll use some real example, medical example, true story. 1849. Let me go to this slide. John Snow was investigating cholera. Right? Of course, caused by polluted water. But the theory was that this has to do with miasmas or air. Right? Landlord dismisses the tenant's complaint that the water stinks, and the tenants are dying. Right? So he is so sure, he goes and shows the tenants, there's no problem with the water. Takes a glass, drinks from it. Dies 3 days later. Right? Now, this happens often. People are about themselves, they're not willing to run experiments. Right? Okay, so this is an amazing story. So now, second stage, people are willing to start collecting the data. Again, true story, Semmelweis. Works at Vienna General Hospital, important teaching hospital. Childbed fever is a disease, again, we don't see today. It killed 1 million women. So he starts to do measurement. he says, what's my ward at? He discovers 15% death rate in his ward, right? Where he's teaching, he's a professor, he's got everything there. And then there's this ward that's attended by midwives, 2%. Wow. Okay, what's the problem? I got to control for things. Okay, maybe I'm getting the tougher cases. Nope, randomization. Maybe I'm more crowded. Nope, the Jasper ventilation, diet. He even gets all the way to how their laundry is sent. Nothing, nothing, nothing. Okay, but he's a professor. He goes on sabbatical, comes back. What did the student tell him? We're down. You're gone, we're down. Not a good message. So here's the insight. Every morning they do autopsies on the cadavers of the women that died yesterday. He comes up with a conjecture that they're carrying particles from the cadavers to the women. So he comes up with this idea of, why don't we wash our hands? Tries a bunch of solutions. Chlorine gets the death rate from 18% to 1%. Amazing, right? Third phase, nobody believes him. It's called Semmelweis reflex if you look it up. Pretty amazing story. So he does this. They let him go out of the hospital. He goes to Hungary, does this again. Students try to publish a paper. They get some editorial comments about how this is not right. He, by the way, suffers a nervous breakdown, believes that he killed all these women. He's not able to convince the world, and he dies. So this is now the reflex. The definition is rejection of knowledge because it contradicts entrenched norms, beliefs, and paradigms. Okay, now is this only in the 1800s? No, 2005 studies. Inadequate hand washing, prime contributed to 2 million healthcare-associated infections, 90,000 deaths, because we're not washing our hands. We haven't learned yet from Semmelweis. Okay, so the last stage, of course, is this fundamental understanding. This is what we all opt for, right? There's a theory that starts to develop. Louis Pasteur comes up and says, oh, it's got to be strep. He shows that this is really the problem. It took a while. 2008, there's finally a euro coin commemorating Semmelweis. Okay, I'll go fast through this. Let me go a couple of slides on challenges so that I've talked sort of historically. What are some of the things that we have to deal with? OEC, okay, coming up with some theory of what to optimize, what is predictive of the long term. Really, really interesting problem. Hard to do for different domains. Talked about improving the sensitivity. Can we reduce the variance? We have a technique that we came up with that we look at data prior to the experiment. Allows us to reduce the variance. Bayesian methods, with p-value, the standard hypothesis testing, is really, really off in the sense that you're testing what is the probability of the event happening, right? This result that I got, is it this or more extreme is the p-value? But given that the null hypothesis is true, what we want is the opposite, right? We want to know what is the probability that my hypothesis is true given the data. So you have to run Bayesian, the classical Bayes rule. Well, it turns out that we have to do this. We have some metrics. I mentioned session per U is our key metric. It only moves in a very, very small percentage of our experiments. So if you have a 5% false positive rate and you're looking at a rate that's 0.002, you're out of luck. You have to sort of adjust for things. Deep analysis, this is where a lot of machine learning can be useful. Experiment ran, I got a Boolean, yes, no. Well, can you find me interesting segments? Can you tell me that this idea was worthwhile for this population of people in my audience? Lots of opportunity here to improve. Form factors, we don't understand. Still we have a theory on desktop that's reasonable. Phones, mobile, how the things change when people don't click. These are things there's a lot to develop. Long-term impact. Okay, as I mentioned, there's a Google paper here on thinking of the long-term. Very nice read. We run experiments for a week. We have metrics that we try to predict. Google tends to run them a lot longer to actually look at the impact over time. Aborting experiments. So every day we have 30 to 50 experiments that start. How can we abort them quickly? Right? We don't want to wait until some of our key metrics become stat-sig. What are predictions that something will be stat-sig so we can abort it down? And then in the whole social world, I'm not going to talk about this, but there are problems with leaks. Control and treatment are impacted by other factors. And this last point happens to us a few times, which is shared resources, right? You're running an A/B test. B hogs all the memory. Okay, ruins A. You're not going to see the result in an A/B test, but it's a bad thing to ship. And then plug in for Yaju's paper. She has a paper here. She had one invited talk yesterday at the workshop. Okay, finally, Hippo. Those of you that have seen them, we love them. So this is a term that Avinash Kaushik and I came up with back in 2006. We had lunch. He said Hippo. I mailed him. I said, we're going to do Hippos. Hippo stood for high potential at Microsoft. That ain't going to work well. Hippo stands for highest paid person's opinion. We made thousands of these Hippos. We encourage you to get some. They're in the booth. Here's an interesting fact. Hippos kill more humans than any other non-human mammal. Pretty amazing. Listen to the customers. Don't let the hippo ruin your day. So here's a summary slide. Think about your OEC. Make sure you know what you're optimizing for. It's how to assess the values of your ideas. Prepare to be humbled. Compute statistics carefully. This is all done like in the Fisher in the 1920s. The theory is well understood, but the practice, the reality, a lot harder. You have to do adjustments for many, many things. Experiment often. If you can experiment more, you're going to find those winners faster. Right? This is why we spent so much time working on making the platform easier to use. Then if you're looking for more papers, there's a site here where we put a bunch of our papers, and then you're welcome to visit the booth, and we have hundreds of Hippos there to hand out. Thank you very much.
Thank you for that inspiring talk, Ronnie. I think that A/B testing is leading the charge to a new world of evidence-driven decision-making, and it's inspiring stuff. We've time for some questions. We've got microphones here. Do you want to select your...
Why don't you run up to somebody?
Thank you for the presentation. So actually, I'm running many A/B testing on my own website, and I feel like I stuck in the local optimal solution sometimes. Like I want to improve the click-through rate on the bottom. I feel like the website became a little bit spammy because I got stuck in the local optimal solution. So in terms of that, I need to connect to the more long-term metrics. So how can we connect the long-term metrics, like click-through rate, to the more lifetime value and a long-term key metrics? How can we do that?
So as I said, it's a great question. One of the challenges, what are short-term metrics that we can evaluate today that are predictive of the long-term? And there's no panacea here. You have to think about how you value the customer long-term. What are the actions going to look like? The only thing I can recommend is run some long-term experiments. See what metrics that you hypothesize are predictive in the short term of being predictive of the long-term result. We do this a lot. We run some experiments for months, and we try to see if there's some things that are predictive. But now we have a small set of metrics that we believe are good enough that we use in most experiments are short-term at Bing. Go ahead, Yes. Oh, cool.
This is Diane. I loved your talk. I agree with 99% of what's in there. I'm from Google.
We passed the statistical confidence.
Yeah, I just wanted to correct one thing. Actually, most of our experiments at Google are short-term in terms of days, maybe a week, same as you. Okay. The paper that we actually talk about where we do run the month-long one is basically exactly about how to do that. So basically how we predict the long-term from the short-term.
Thank you. There's a...
What about non-Bing experiments?
So we so focused here mostly on Bing just because of the scale and the fact that we understand it. We are running experiments in other groups. We are not as evolved in our understanding of the OEC and many, many other things that are happening. But it is, of course, the charter for our team at Microsoft is to be company-wide to help everybody. So you're going to start to see experiments. There are experiments on Skype now happening. We ran an experiment on Exchange recently. There's even an Xbox experiment that ran a couple of months ago on the console where people got different, let me see if I can, I'll mention this. So in Killer Instinct, which is one of the games that we give out for free, we made some variations and people are in an A/B test. So it's happening, it's coming. Let's go to this side. There's a person there.
Since you run so many variants and experiments, is there a way of learning meta feature? You mentioned one, bigger size is more click-through. Is there a systematic way of doing that?
So if I understand the question correctly, you're asking us to sort of, are there generalizations of rules that we can come up with?
And help you design new features.
Yeah. So look at last year's paper at KDD. We call it the 7 rules of thumb. where we try to come up with these generalizations that are normally true. Remember, bigger size gets more click. It's normally true. You can't make the button the whole page and expect it to be useful, right? So there's limits to what we can do. But yeah, so we have multiple rules that we came up with that are useful. Faster is always better, but where does the time matter? It matters in the first, until you start pumping data into the visible screen, things like that. So there's a bunch of rules like that. Person there.
Ronnie, you and I have talked about this before, and we can talk offline. But these are all relatively simple A/B tests, given the fact you have complex confounding effects. But if you think of a systematic selection bias that things like targeting engines, recommenders induce, what are you doing to handle these? That's something people might find useful, I think.
So I'm not sure I understand the question. I mean, you can A/B test a new variant of your recommender system. We do that all the time.
Yes, but what I mean is if you have, many of the papers, I mean, not the ones you referred here, Yahoo and others, have been about phenomenological effects of a systematic selection bias, right? People who browse more tend to buy more type of thing. But if you think of whether it's a targeting engine which optimizes user selection or recommenders, you're essentially setting up a systematic bias, which is a selection bias. So you need to account for that.
So I'm not sure I get that point. Why am I mean, I'm splitting the users randomly. So at that point, there is no selection bias.
Yes.
Okay, so where are you talking about the selection bias being introduced?
Yeah, but once you have the targeting engine, then you no longer have statistically equivalent population. Think of you bid, you win an auction, lose an auction, or whatever, right? Then you no longer have statistically comparable population. The whole the randomization conditions break down. So when that happens, you need to compensate. And we've written papers on how to fix that. But I was wondering how you folks are addressing it and how the broader community is addressing it. It seems a systematic error that people are making.
Yeah, so I think you're talking about what we call leaks, which are if there's a learning system and it's being exposed to the control and the treatment, it's being impacted by the experiment in different ways, right? So it's a great question. I think I'll put it, it's one of the challenges that I put up there is sort of, we call them leaks. We don't have the magic pill for that. What we will do at times is when we suspect that, we will run 50-50 to make sure that the impact is the same. So there is an advantage if you run a controlled experiment. There is an advantage to the larger group at times. So the classical example is you have an LRU cache, right, the least recently used. If you have that, and the control gets 90% and the treatment gets 10%, the LRU is going to fill up from the control, and it's going to make that page faster. So we encourage the teams to always run equally sized groups. So they'll run 10-10 or 20-20. We tend to rarely run these unbiased variants. That partially addresses your issue. There's something that I'll just admit we don't know how to handle with controlled experiments. I mean, there are second-order effects. When you run an experiment and you somehow manage to increase revenue, say, the advertiser may take a while to adjust their strategy for bidding. That may then negatively impact you. Those cycles are longer. They're harder to assess. There's some theories that the organization has built about, what is the revenue coming from, what really counts, what is not. And we have mechanisms to test the actual end result, the conversion to action that the advertiser do. So we have a little bit of theory there. I can't claim it's as advanced as some of the things that I've talked about here, and I think it's an open, great question to work on for people.
We're going to have to pull to a close there. Thank you very much. Longbing has a word to say, and while he comes to the stage, please join me in thanking Ronnie.
Thank you.
So IT, can you switch to the slides, please? So start from today, basically I have a one-page highlight for the day. So today, as you have probably already know, we got an exhibition we started today, and we have 16 parallel sessions. We have, in particular, I want to highlight we have 6 industry-invited talks that we're having at State Room on level 2, and then we have 3 tutorials at room 6 and 5, and combined room on level 1. And most importantly, for those 230 presenters, including the research industry, government, and KDD Cup presenters, you will come back to this room at 5:15 and start to set up your poster session. Because this year we have a largest number of posters, so we have to do it properly. So that's why I need to highlight. And we got a poster board Cherno or somewhere. But anyway, so when you have time today, you go to the registration desk. And behind the desk, there's a poster, border map, and with a sequence there show the number of your poster, and you follow the map, and you can talk to Brooklyn, and she can explain the process and how can you find your border. And when you come in at the 5:15, and there will be two border poster on both sides, close to the entrance, and you can actually follow it. And volunteers here, where this KDD 2015 T-shirt will show you to your board, and you can put your poster on. And but by 9 o'clock, we have to close it because I have to clean this room for tomorrow. And once again, the food and beverage will be offered, and just enjoy. And another thing I want to highlight here, we have another small gift for you, and actually this one more KDD USB. So if you want it, just go to the registration desk, collect it. Enjoy the day. Thank you very much. Bye.